Hello, welcome inside the mind of Matt, and it's time to melt some more metal. This time, I'm going to 3D print it. That's right, I got this Virtual Foundry 87% bronze filled filament, and I'm going to print some. If you want to check it out, make sure you watch the rest of this video. Stay tuned. So once again, I'd like to thank the folks over at Virtual Foundry for giving me this roll of filament at Murph to try out for the channel. So I got a link in the description for their website and everything as to where you can get this stuff. This is the bronze fill, and it is 1.75 millimeter. It says that it's 87% bronze. Now, in order to print this, there's a couple things you're going to need. Okay? First, you're going to need the filament. Check. 2, I'm going to need a bigger spool holder. Check. And you're going to need a model. Check. And then, of course, you're going to need a special nozzle. What kind of nozzle is needed to print?
Just a regular brass nozzle.
Yes, a regular brass nozzle will work, but you're going to need a bigger one. So, according to the website, you're going to want a 0.6 millimeter or bigger. So I have to put this nozzle. I'm going to be breaking out Mo, which has a E3D Titan Arrow extruder on it. We're going to load this up. I've got a model that I've designed up just for this particular project. So let's go to printing. Alright, so I got my extruder in position. I am going to put this 0.6 millimeter nozzle on, and then we're gonna show you the model. I'll slice it up, and then we'll start printing. Now remember, anytime you replace your nozzle or do anything with your hot end, you might want to check and make sure that you're not hitting the bed and crashing. So we're going to have to do a little bed leveling, and we're going to load up this filament, and we're going to try to print something. And before I do, I'll show you this model. I keep talking about it. I designed it. It came to me, kind of hit me in the head like a weapon from a game. That's a clue. Oh wait, that's another clue. Ah. You follow me yet? Keep watching. Here we are. I'm going to open up Simplify 3D. Now I have copied my Mo profile and a couple things that I've changed. Obviously I changed the nozzle to 0.6 down here as well, and I'm making my layer height at 0.4. Everything else except for the speed, which it tells me to print kind of slow, so I'm going to start at 30 and see what happens. So now the model, where is it? There it is. A candlestick. I designed this up in Fusion 360, which I'm not going to show you how I did it, but if you're interested in this, I will put it up on Thingiverse if anybody leaves a comment in the comment section saying they want it. So I'm going to send that off to the slicer. We're not even going to do a test model. We're just going to go straight for the gusto and print this. It's going to take 2 hours and 49 minutes. Alright, the model's loaded, the printer's warmed, and I'm about to press the start button. So here we are just at the second layer already, and I'm already paying attention and everything, and one of the things that I've noticed is that it's starting to drag some of the filament across the top of it. So what I've done is I've slowed it down to 80% of its speed, and it seems to be doing a lot smoother. Being familiar with printing with other types of filament like PETG is one of the filament types that if you print too fast it's going to start to ball up right on the end. So you slow it down, it has enough chance to lay the layer down and have it stick to the previous layer and not to your nozzle. So I think I've got the speed adjusted. The temperature is at my normal PLA at 210, 40% fan, because this is a super powerful fan. 50 degrees on the bed, using a little magic goo, and we'll hope that this will last. Now, because I've slowed it down, I know that my slicer is going to be a lot wrong. So it's probably going to take 4 to 5 hours. So hopefully the time lapse, I actually turned octo-lapse off because of the things that it was doing to the top. I don't know if you noticed right in the center. It's where it goes to take its snapshot. But we'll still get a time lapse of this printing. So let's let this thing go. Well, something wonky's happened. I'm going to have to stop this print. But it's sliced up kind of weird, and I don't know if you can see, but it didn't print a bunch of infill, and then it started to print the top layer. But something's not right, so I'm going to stop it and probably reslice it and start this again. Alright, so I'm warming up for attempt number 2. I want to get a look at this. So what happened, and the slicer did this, I just stopped printing infill in this area here, and this was just kind of air printing. Now I have adjusted my speed in the next time that I sliced it, as well as I've adjusted my temperature a little bit. I was printing at this at the beginning, the first couple layers at 210, and I lowered it to 205, and it still seems like it's printing good, but this little bit right here is very, very heavy. It's kind of unreal to feel. It feels like metal, you know. So anyways, this is about heated up, and we're gonna go for attempt number 2. Alright, so the first layer of the second attempt is just about halfway done, and just the speed and temperature adjustment of 5 degrees lower and 10 millimeters slower has made a major improvement. We're going to see how this is going to go. It's going to take a little bit longer, but we're going to let it just go nice and slow. Okay, so here we are at the point at which I stopped the first print. And as you see, that top layer, it's not really the top layer, it's the bottom of the top layers, which I have 6 top layers set in my slicer settings, but it's just kind of like draping it on top of the infill, which seemed to have sunk down inside the model. So it's something I'm going to have to look at. I'm going to let this print some more and see what it's actually going to do. Make sure we're not going to have any weak spots or anything like that. But just one of the things I'm noticing that's a little bit different. I don't know if it's the filament or the fact that I'm using a bigger nozzle and larger layer heights. Who knows? But we'll let this thing keep printing and we'll see how it turns out. Alright, so it's gotten a couple layers higher above the sunk in, which appeared to be sunken infill. Kind of like this is the first failure, if you kind of see. That's what I was seeing, so I stopped it. But as you see, it's gotten a couple layers on top of that, and it's getting nice and flat and smooth and nice. So I might have just been a little bit nervous and prematurely pulling this from the print, but at least now I have something to do a little bit of experimenting with, and maybe we'll get some of that in this video later on. So I've got a little while before this is done printing, so I'm just going to keep watching it. Alright, it looks like our candle stick holder came out pretty awesome. It's heavy. Alright, I guess I'll clean this thing off and start something new. Alright, so up next I printed my maker coin, because why not have a bronze maker coin? It'll kind of be one of a kind actually. It's actually printed better than the vase. There's still like some surface fuzziness to it. It feels like wood, except for it's heavy. I don't know if you've ever printed in any type of metal, but it's heavy. I've got just a couple strands left. I do have one more model in mind that I think would be appropriate in some fashion. But I'm going to load that up and we're going to print one more thing, and then I'm going to talk about this filament. Okay, so I adjusted my settings a little bit and I made this a 0.2 millimeter layer height. Look at that, supports pulled off. The lettering came out. You have to do a little cleanup of the supports. But I still have some left, so I might just save this for another project. But let's go with the rest of the prints and let me give my thoughts about this filament. Okay, so the next thing I want to talk about really is the next process to what this filament is capable of. Now, I could polish this, you know, going through one layer at a time or one grit at a time and working my way up, and there's a whole process that they've given on their website, which once again I'll leave a link in the description. But there's a process to go through to shine this up, and then you can fire it and go through a process and make it so it's pure metal. And some of the process involves in getting what they're calling black magic powder, mixing that with water, I believe it was, and painting your model,
and then submerging it at basically creating a mold of this black magic powder, which then you'll dry, which is the candling process, and then he went through at the show giving all the different processes, but you're basically heating this thing up to the point where you're melting the metal right out of it, which, not to take away what this is capable of, but if you're capable of doing that, I mean, wet lost PLA process is within your grasp. It's still about the mold hurdle that has to be crossed at that point. But I digress. Back to this. So the next process of this for me is going to be to polish this, which I'm not going to do in this video. But if you would like to see a video about it, make sure that you leave either a like or a comment in the comment section saying that you'd like to see me mess around with it. Now, I do have this part that was the failure that I will probably be doing most of the experimenting with to start, as far as try to polish it, try to use a soldering iron just to see what the effects. Maybe I'll sign it or something, but I'll definitely be experimenting with this. So if you would like to see a video about that, make sure that you leave a comment in the comment section. So let's talk about the filament itself now. The one con that I will get right out of the way from the get-go is that it's expensive. It's an exotic filament, and it's going to cost more than your average PLA. So this roll that was given to me would cost $80, and then it would also involve shipping and handling, and of course if you wanted to finish the process, there's another $12 or $13 for the black magic powder and stuff. So it's costly, and it's also done by weight, not by length. I mean, no filament is sold by length, it's sold by weight, but a lighter filament obviously is gonna be a little bit longer than a heavier filament. So experimenting or trying to fine-tune your settings for this particular filament, that's one of the cons that I'll have to add on the list, that because of the cost of it, you're not getting a lot of it. So fine-tuning, you got to make sure that your machine is kind of spot on before you're going to want to print this. So because of the cost of it, and because the amount that you're going to get, it's going to be more of like a specialty project, or something that you're trying to prototype, or an absolute specialty type of gift, or something that you absolutely have a purpose for, because it's not something to be printing a bunch of maker coins and benchies and stuff like that with. So, but as far as all of the setting recommendations that they put on their website and on the labeling, it pretty much printed at those temperatures and speed. I did slow it down a little bit. So I ended up with this ring, I ended up with 20 millimeters per second. And once again, that's arbitrary because of my acceleration settings versus your acceleration settings and jerk like that. But I printed it slow. Bed adhesion, I ended up just using magic glue, but like they said on the website, that bed adhesion is great with this, mainly because it's heavy. So once you lay down a couple layers, it's pretty much, like a rock sitting there. It's not gonna move easily. I didn't experiment without any bed adhesion, but I did use magic goo, and it worked perfectly. Now when you are printing this, I've printed at a 40% infill. Now, and if you saw that it kind of sinks in, so I'm not sure exactly if a higher infill would have fixed this, or a lower layer height. I did print the candlestick at a 0.4 millimeter, and I printed the ring at a 0.2 millimeter, and the maker coin I also printed at a 0.4 millimeter layer height with a 0.6 millimeter nozzle, 0.6 nozzle. So, I mean, it's heavy. I did print just for, you know, this is just a regular PLA maker coin. This is a bronze PLA maker coin. Big difference. This is a PLA candlestick holder. This is a bronze PLA candlestick holder. Pretty heavy. Now the other thing is if you saw the way this printed it from the video, that you can, it sounds hollow. So if I was to fire this, I'm almost afraid that it would kind of like melt inside of itself. So, but I am going to polish this up in a future video once again. If I get enough people requesting it, then I'll definitely do something with this. So anyways, that's pretty much my take on the Virtual Foundry bronze fill PLA. I will have a follow-up video if I have enough requests as far as how to shine this up, and I do have enough left to maybe come up with another design to print. So if you like this video, make sure that you hit that like button, subscribe if you haven't, and if you have, I appreciate your support. Make sure you let those ads play. Check out all the links that I have in this description for any shopping that you'd like to do. It helps out the channel. Also, if you'd like to buy me a cup of coffee or support me on Patreon, the links are down there as well. Appreciate those that do support me on Patreon and have bought me a cup of coffee. I appreciate it. It helps out the channel. Thanks for stopping inside the Mind of Matt. Happy printing. Be safe pouring. And keep on coming back, because there's going to be more.